This is a set of coils. If you place it over a magnet and move it back and forth, it generates an electric current. If you connect a light bulb to the circuit, the light will start to flicker. This is the basic principle of how generators work, which is also known as electromagnetic induction. To get a better handle on this, let's break down this phenomenon first. First, the magnet itself has a magnetic field. While the coil doesn't have a field of its own, it does contain disorganized free electrons. When we move the magnet back and forth, as the magnetic field passes through the coils, the magnetic flux increases and decreases. This change in the total magnetic field forces those chaotic free electrons inside the coil to all flow in the same direction. This steady flow creates an electric current, but this current isn't very stable. To produce a steady flow of electricity, you smartly wind copper wire into a tight coil, wrapping it around a central shaft, and place a pair of strong magnets on both sides. As the coil begins to spin, with every half turn, the direction of the magnetic field through it reverses. This periodic shift in magnetic flux within the coil triggers a continuous alternating induced current. To make the rotation more efficient, you attach a gear to the shaft of the coil, using a chain and a hand crank to drive it. Spinning it at a steady pace creates a stable current. Congratulations, you have just invented a hand crank generator. If you place a boiling kettle behind it and use the steam to drive the motion, then congratulations, you have just invented a steam generator.